So we are taking 1 kg of water at 273 Kelvin that we are making in contact with 373 Kelvin reservoir. This is my reservoir. So if you make contact of 1 kg of water at 273 to a reservoir of 373, then what we can expect? We can expect that the temperature of the water will rise, and after some time it will attain the temperature of the reservoir. So the temperature of the water rises from 273 to 373 Kelvin. So ইমানখিনি তোমাৰ temperature to rise হৈছে. So if the temperature is rising from 273 to 373, now they are asking to find out the change in entropy of the water, of the reservoir, and of the universe. So here the water is the system, reservoir is the surrounding, and we have to find out the change in entropy of the system, surrounding, as well as the universe. So মই যদি প্ৰথমতে সিস্টেমৰ যদি চেঞ্জ ইন এন্ট্ৰপি উলিয়াও, তো চেঞ্জ ইন এন্ট্ৰপি অফ ওয়াটার কিমান হ'ব? 273 to 373 dq by t. So dq by t means, what is your dq? How much heat it will take? How much heat it will take? The water is in contact with the reservoir and its temperature is rising from 273 to 373. How much the heat will the water will take? How much heat it will take? You think is tell me the formula. I don't know. Ms dt. So Ms dt means mc dt by p. Now m is equal to 1 kg, c equal to your how much? c to given over specific heat of water 1 in CGS unit. SI unit কি হবে? 4200. Okay, 4200. So এটি তোমালোকে SI unit লিখা বা CGS লিখা, it's up to you. If you want to write in CGS, then everything has to be made in CGS. Otherwise, you have to write this C in terms of SI unit 4200. So it will be equal to 270 or mc dt by t. This will be your ln of here 373 divided by 273. So this much will be your change in entropy of the water. If you are writing this in Kelvin, this also you have to write in SI unit. This also you have to write in SI unit. So accordingly you will find out, and the answer will be 1311 joule per Kelvin. 1311 joule per Kelvin. Now what will be the change in entropy of the reservoir? Change in entropy of the reservoir or the surrounding. How much? Minus dq by t. So dq is how much? mc. This minus this, mc to 373 minus 273 divided by 373, and this will be equal to, the answer will be 1126 1126 joule per Kelvin. So what will be the change in entropy of the universe? This plus this. So it will be it will be coming out to be around 185 joule per Kelvin. 185 joule per Kelvin. So you see, it is not equal to 0. It is greater than 0. So it is an irreversible process. But for reservoir, you see, for reservoir the change in entropy is 0, less than 0. It is in negative. So for a system or the reservoir, the entropy change may be less than 0. But if you talk about the universe, it has to be always equal to 0 or greater than 0. It cannot be less than 0. The entropy change in entropy of the universe cannot be less than 0. System or hobo pare, surrounding or hobo pare. Okay. Now here one important thing. Till now we have calculated the change in entropy for reversible process as well as irreversible process. Kintu amar jontu entropy definition ase, change in entropy definition ase, that definition of change in entropy is only valid for reversible process. Okay, change in entropy only can be calculated for reversible process. For reversible process, change in entropy can only be calculated for reversible process. But আমি তো কি কৰি আছো, we are calculating the change in entropy for both reversible as well as irreversible. So সেইটো কৰিব কাৰণে আমি এটা assumptions আমি লওঁ, আৰু assumption টো হ'ল কি যে all reversible, all irreversible processes are replaced by a reversible path. All reversible process or path are replaced by a reversible path when the initial and final states are in equilibrium. So যেতিয়ালৈকে মোৰ initial state আৰু final state equilibrium থাকিব, in that situation I can replace the irreversible part by a reversible part. And once we replace the irreversible part by a reversible part, then I can calculate the change in entropy. For example, if you see, last class this is an irreversible process. And this is isothermal process. It is a reversible process. So reversible process for the reversible process, we got the value to be like this. This is my value. Same value I am taking here, but this is what? A irreversible process. So what I can assume here, I can assume that the initial state or final state of equilibrium in that situation is into path he follow koribo state A plus state B, that means V1 or V2 look at that whole path I can replace by a reversible path. A reversible path lole hai mathematically I can calculate the change in entropy. So this is a very important conclusion. That change in entropy to kintu actually the definition of entropy comes from that reversible process of right. Irreversible process jodi ami calculate koribo laga hoy, whole path will be replaced by an reversible path. গতিকে আমি স্মল ষ্টেপত আমি কি কৰিব লাগিব ভাগ কৰি ল'ব লাগিব and then only I can calculate the change in entropy. So now let us go for another example. Etu example hoise and this you have to do the practical also. Etu practical tomare koribo lagibo. An electric current 10 ampere is maintained for 1 second in a resistor of resistance 25 ohm. You have a resistor 25 ohm and you are allowing 10 ampere current to passes through it for time t equal to 1 second. 25 ohm resistor madhore tumi 10 ampere current pothai asa for 1 second. While its temperature kept constant at 27 degree Celsius. Temperature to moi kihot constant kori rakhisu 27 degree Celsius. Temperature to moi constant kori rakhisu. So I am keeping the temperature kept constant at 27 degree Celsius. Calculate the change in entropy of the resistor and the universe. Okay. So if you want to make the temperature constant, how you can make the temperature constant? Because তুমি যদি কারেন্ট পঠোৱা ৰেজিস্টাৰটোৰ মাজেৰে কি হ'ব হিট ডেভেলপ হ'ব the resistor will heat up আৰু ৰেজিস্টাৰ যদি হিট আপ হয় টেম্পাৰেচাৰটো কি হ'ব বাঢ়ি যাব কিন্তু মই এতিয়া কি কৈ আছো টেম্পাৰেচাৰটো কনস্ট্যান্ট ৰাখি আছো how you can do that কি কৰিবা how you can make the temperature constant you are allowing 10 ampere current to flow through it টেম্পাৰেচাৰটো কেনেকৈ কনস্ট্যান্ট কৰি ৰাখিবা any method that you will apply temperature can constant kori rakhiba temperature jodi constant kori rakhibo laga hoy moi ki koribo lagibo first of all what I have to do whatever heat develops tak moi ki koribo lagibo I have to drain it out tarpor resistor par automatic mane heat to develop hoy loge loge that heat has to be taken out from the resistor so I should have a mechanism and that mechanism should take all the heat generated in the resistor immediately from the resistor. So what I can do, I can put that resistor inside water, a big reservoir, but I can do one thing, I can allow water to flow over the resistor. Resistor to ase ma pani jabo di ase tar upor. So jetia ma current din whatever heat develops, ei pani khine ki koribo? The water will take out the heat and temperature will maintain at 27 degree Celsius. So in that situation they are asking to find out the change in entropy of the resistor and the universe. Resistor universal change in entropy uliyabolise. So it will be resistor aru universal jodi change in entropy uliyabo laga hoy what will be the first of all what will be the change in entropy of the resistor change in entropy of the resistor can anybody tell me what will be the change in entropy of the resistor what will be the change in entropy of the resistor and what will be the change in entropy mok universe to jodi lage universe kare mok ki lagibo resistor is the system aru mo jitu water tar upore jabo di asu that will be my surrounding so this is my surrounding so ei duta mok lagibo ei duta jodi gom pao then I can know the change in entropy of the universe what is the surrounding the water that we are allowing to flow over the resistor. What is the system? Resistor is my system. So now the question is what will be the change in entropy of the system that is the resistor. Can anybody tell me? Okay, what will be the change in entropy of the surrounding? Surrounding is your water. So the change in entropy of the water kiman hobo? Any idea? We have a resistor that temperature to maintain to actual temperature 27 degrees Celsius. That means I am not allowing the heat to affect the resistor. Whatever heat develops, the water is taking the heat. So what will be the change in entropy of the resistor? 0. The change in entropy of the resistor will be 0 because that resistor echo change one system. I am not allowing to change the system. Whatever heat develops, surroundings. So whatever develops, it goes to where? Surrounding. So the system or echo change one. Whatever change is happening, that is happening to the surrounding. So what will be the change in entropy of the surrounding? I square R into T, because that much heat is developed or heat what I is giving to the surrounding. So surrounding of tomorrow I square R into T, and we are about tomorrow 0. So it will be you can put the values here. 10 square into 25 ohm into 1 second. So ultimately, it will be 2500 joule per Kelvin. The change in entropy of the universe will be 2500 joule per Kelvin. So this is the change in entropy of the universe. System কিমান হৈ আছে? Systemত হৈ আছে 0, surroundingত হৈ আছে ইমান. So surroundingত যিমান হৈ আছে universeতো ইমান হৈ আছে because systemত কোনো effect কৰা নাই. Now, same thing, same resistor, what we will do, if the same resistor is now thermally insulated and its initial temperature is 27 degrees Celsius. Calculate the entropy change of the resistor and the universe. এতিয়া মই কি কৰিম, এই যোনটো resistor আছে, resistor temperature কিমান মেইনটেইন কৰি ৰাখিছো, 27 মেইনটেইন কৰি ৰাখিছো. Now I will do one thing. Now I will make it thermally insulated. Thermally insulated. I will make it thermally insulated. So I am making it thermally insulated. And initial temperature is what? Pi is equal to 27 degrees Celsius. Same 10 ampere current for 1 second. But only difference is that the resistor is now thermally insulated. Now what will be the change in entropy of the surrounding? 0. Because you are thermally insulating, no heat is going to the surrounding. So change in entropy of surrounding del S. Now change in entropy of the system, that means the resistor, change in entropy of the resistor কিমান হ'ব? Now you see your resistor is thermally insulated. Thermally insulated means what? The temperature will rise. It will rise from 27 degrees Celsius to another temperature called TF. So first of all, I have to find out this TF. Then I can do one thing. I can integrate it from Ti to TF. Okay. So mc dt divided by T. Because your temperature is rising from Ti to TF. So if Ti per TF tomorrow temperature will rise, then the amount of heat taken will be equal to mc d theta, which is nothing but I square R into 2. Because that heat বাঢ়ি গৈ আছে, whatever heat develop in the resistor, সেইটো ক'ৰ পৰা পাই আছোঁ? দিছ I পৰা পাই আছোঁ। So the heat develop is nothing but I square R into T. কিন্তু টেম্পাৰেচাৰটো কি হৈ আছে? বাঢ়ি গৈ আছে। গতিকে তাক মই কেনেকৈ বুজাব পাৰোঁ? MC dt। গতিকে এই যোনটো আছে equation MC dt will be equal to I square RT, ইয়াৰ পৰা মই কি ওলাব পাৰোঁ? From here I can find out this TF, because MC dt is nothing but your MC TF, MC TF minus TI will be equal to I square RT. TI I know, M I know, C I know, I square into RT, that already I know, is 2500. So this is 2500. TI is 27 degrees Celsius. MC I know, so I can find out F. TF I can find out. TF I can find out. And if you find out this TF will be equal to so you have to find it out. You have to find out the value of this TF. You have to find out the value of this TF. TF for value to be you have to find out this value of TF. And once you got the value of this TF, now you can integrate it from TI to TF. You can integrate it from the TI to TF. Then it will be your using this formula, to use using this formula, you can find out the change in entropy of the resistor. So, change in entropy of the resistor will be this much. Change in entropy of the surrounding will be this much. So, total change of entropy of the universe will be this plus this. So, as a homework you do. You find out the value of these things. M is 1 kg. 1 kg lose M is 1 kg. Mass 1 kg resistor lose mo. Okay? So you do this one. And this is into my second example. Practical. You have to do practical also. You will be given a resistor, you have to make it diametrically close, then you have to find out the change in entropy. So you have to so there are lots of examples. Not only assignment did him, some assignment I will be given to you regarding some numericals. And ইয়াতে তোমালোকৰ দুটামান বস্তু তোমালোকক কৰিব লাগিব। এটা হ'ল you have to find out the change in entropy of a perfect gas, ideal gas or change in entropy. Secondly, you have to find out the efficiency of Carnot engine using TS indicator diagram. So now we have TS indicator diagram. TS indicator diagram. We already got PV indicator diagram. Now we'll have TS indicator diagram. It is TS indicator diagram of usually এটা isothermal process তুমি indicate কৰিব লগা হয়। If you want to show an isothermal process in a TS indicator diagram, how you will show it? কেনেকুৱাকৈ show কৰিবা? There will be a straight line. Okay, temperature will be remain constant. So this is nothing but your isothermal process. Now for an adiabatic process, কি হ'ব? For a diabatic process, there is no exchange of heat, so entropy will remain same. So that will be called isentropic process. जो हमारे entropy जो एके থাকে, this is called isentropic process. Isentropic process. Isentropic process is a process where your entropy remains constant. So similarly, I can represent isobaric process and isochoric process. That also I can represent. কিন্তু ইয়াত তুমি যেতিয়া isochoric আৰু isobaric process to তুমি দিবা, then it will be looks like this. Okay, this is isobaric, this is isochoric. জাস্ট অপোজিট PV ইণ্ডিকেটৰ ডায়েগ্ৰামত আমি যেতিয়া আইচোথাৰ্মেল আৰু এডাবেটিক আমি চাইছিলোঁ কেনেকুৱা আছিলে এটা কাৰ্ভ আছিলে ন আৰু আইচোবাৰিক আৰু আইচোকৰিকটো কি আছিলে ষ্ট্ৰেট লাইন আছিলে সো ইয়াত জাস্ট উল্টাটো হৈ আছে আইচোবাৰিক এণ্ড আইচোকৰিক আৰ নাও কাৰ্ভ isothermal and adiabatic are now straight line. Okay, so here tomar slope loi kotha ase I am giving you the notes tat likha ase isocoricor slope besi hobo ne isobaricor slope besi hobo just like your PV indicator diagram ami isothermal slope besi asile adiabatic slope besi asile we have find out. So here also we have to find out whose slope is more, isocoric or isobaric. I will give you the note in the side. Okay, this is important. Idia mojuri yat PS indicator diagram mojuri Carnot cycle to jodi moi represent koru. If I want to represent the Carnot cycle, tumra ko pariba ne kenko hobo? What will be the Carnot cycle here? Carnot cycle to kenko hobo? It will be a square or maybe rectangle. Okay, so this is isothermal expansion, adiabatic expansion, isothermal compression and adiabatic. So this will be my Carnot cycle in PS indicator diagram. And here you have to find out the expression for efficiency. So I will give you the notes. If you are more so this you have to do. Also you have to find out the change in entropy in case of a perfect gas. That notes also I will give you. Now let us come to the main part of your entropy, which is the physical interpretation of entropy. How we can interpret physically entropy. আমি প্রথমতে mathematical aspect to salu. Iti ami physical aspect to sum. So mathematical aspect to salu ami what we were able to do. We were able to calculate the change in entropy. Kintu we don't know entropy to change howa mane what is actually changing we don't know. Now we will try to understand that the entropy to change howa mane actually ki change hoye ase that we will try to understand. So mathematical aspect to go. Now we will go for the physical aspect. Physical interpretation of entropy. Physical interpretation of entropy. I mean entropy to it key hoy that you will see. So mathematically Clausius has put forward a term called entropy, which was defined as the amount of heat taken or given divided by the temperature. And from there I can calculate the change in entropy for various systems, reversible, irreversible, all systems I can calculate the change in entropy. Now we will try to understand what is the physical significance of an entropy. And hetu bujibor karone let me consider a cylinder having some gases. Now this physical interpretation of the entropy was given by Boltzmann. It was given by Boltzmann. Mathematical aspect to Clausius. Boltzmann has given the physical aspect by a very small equation S equal to K ln of omega. It is written in our wall also. S equal to K ln of omega. This is the Boltzmann equation for entropy, and it took 20 years for Boltzmann to give this relation. So it is not a joke. So entropy is into physical interpretation. It comes after 20 years of its invention. 20 years ago, manu buji pon asile what is entropy. After 20 years only, after giving the Boltzmann expression S equal to K ln of omega, people were able to understand or visualize what is entropy. Where K is the Boltzmann constant, this is nothing but the probability. Omega is called the probability. So we will first see this. It was to me some through an example. We will see how this equation tells us about entropy and how to visualize the entropy physically from this equation. Because Clausius equation of I physically only mathematically I can calculate the change in entropy. But now I can know the entropy of a system. The A2 state of entropy is A2 state of entropy is. Now I can calculate that. Clausius change in entropy. He only tells us that whenever we go from one state to the another state, there will be changing something, and that something we call as an entropy. You know, don't know. I mean, change in entropy directly we will find out the entropy. That a system of entropy will. So for that purpose, let me consider a cylinder which having some gases here, and we have a partition here. Imagine that there is a partition here. We have a partition. Because the partition can beside you, all these gas molecules will distribute among this cylinder. I will not remove the partition. I will take one molecule and put it on the other side. Here a molecule, let me consider there are 100 molecules. So how many molecules now we have? We have 99 here, 1 here. Okay. There is another state I will consider. I will take one molecule here and all these 99 molecules in this side. Let me call it as a left side and let me call it as a right side. This is right side, left side. Okay. Probability. If I want to keep the gas in this state or in this situation and in this situation, probability or how many ways we can do this. The left of 99 ta ase, right of eta ase. Hetu kiman ways of tumi pariba? How many ways you can do that? If the gas molecules are identical to thoru, mo etai way ase. Ipine 99 thakibo, ipine 1 thakibo. You can etu yate ni pela beleg eta anibo para, still 99 1. Aru ta beleg ani pela etu yat dibo para, still 99 1. So 99 1 thaka step to ki ebare pai ase. Yes or no? Similarly, etu mo ki pai ase? Ebare pai ase. Because etu mo et dilu beleg eta anilu, ako eta dilu beleg eta anilu. So still it is 99 1. Now duta law. This is 98 2. 98 2. Now you can do two different ways. Mane 1 to be 1 equal 99 equal 1 demand wasila. If 2 0 to you can do more number of ways that you can find out using your formula called permutation combination to use you can do that. We are not going to do that mathematically to correct. To be duta nolai to be tinta law. So this state more number of ways to be power. You take 4. So you increase this. Increase kora to me 50-50 kora. That means here it is 50, here it is 50. If it is 50 ase, it is 50 ase. So how to be kiman ways of power? Not many numbers of ways. Okay. In fact, to me mathematically this 50 state into ase, that state you can get 2 to the power n times. So where amar n equal to kiman ase? 100 ase. So এই যোনটো ষ্টেট আছে 50-50 ষ্টেট, ইপিনে 50টা ইপিনে 50টা, সেই ষ্টেটটো I can get 2 to the power n times. কিন্তু মই যদি ইপিনে 100টা আছে ইপিনে 1টা আছে, it will be naturally far more less than 2 to the power n. Mathematically probability ফালৰ পৰা you can find it out. এইটো ক'ব পাৰা। So that means what I can understood from here is that এই যোনটো এটা ইপিনে থকা আৰু 99টা ইপিনে থকা 99টা ইপিনে থকা এটা ইপিনে থকা সেইটোৰ probability কি হয় বহুত কম। That means very small number of ways you can do that compared to the situation where you have 50 here, you have 50 here. ইপিনে 50টা আছে ইপিনে 50টা আছে, সেইটো তুমি বহুত বেছি নাম্বাৰ ওয়েজত কৰিব পাৰিবা। ওকে, এটা সাপোজ মই ধৰি ললো যে I can replace this all. That means ইয়াতে মোৰ এটা আছিলে, if I have only one here, I have only one and I have assumed that I can bring it here, তাৰপিছত মই ইয়াত লৈ যাব পাৰোঁ, then I will bring it here, then I will take this to this. এনেকুৱাকে তুমি কিমান বাৰ কৰিব পাৰিবা? 99 times কৰিব পাৰিবা, because you have 99 numbers here. So 99টা মলিকুল যদি আছে, 99টা মলিকুলটো ইপিনে ৰাখি 1টা মলিকুল ইপিনে ৰাখাৰ মই কিমান বাৰ কৰিব পাৰিম? 99 কৰিব পাৰিম, if I allow all the molecules to go like this. If I allow that these are not identicals, এখানে যে আইডেন্টিক্যাল নহয় বুলি মই ধৰো, তেতিয়াহ'লে মই এবাৰ ইয়াত নিম, নেক্সট টাইম মই এবাৰ ইয়াত নিম, নেক্সট টাইম ইয়াত নিম, নেক্সট ইয়াত নিম। So like that I can do 99 times. কিন্তু মোৰ যদি ইয়াত এটা নলগে দুটা লওঁ, তেতিয়াহ'লে কি হ'ব? নাম্বাৰ ওয়েজটো কি হ'ব? ডাবল হৈ যাব। তিনটা ল'লে আৰু বেছি হ'ব, চাৰি ল'লে আৰু বেছি হ'ব। নাও ইমাজিন 50-50. So 50-50 হ'লে কিমান more times you can do, and that will be nothing but 2 to the power n times. So what I can understood here is that ইপিনে 99 ৰাখি পেলাই ইপিনে 1 ৰাখি পেলাই যিমান টাইমছ বা যিমান ওয়েজ তুমি পাবা, ইপিনে 50 আৰু ইপিনে 50 ৰাখি you can get lot many number of ways. That means 50-50 situation you will get lot many numbers of ways compared to 99 and 1 and 1 and 99. Is it clear to us? যে ইপিনে লেফট সাইডে 99 রাইট সাইডে 1 থকা হেতু যিমানটা ওয়েট মই পাব পাৰো, আৰু লেফট সাইডে 1 রাইট সাইডে 99 হেতু মই যিমান নাম্বার অফ ওয়েজত পাব পাৰো, 50-50 যদি কৰো হেতু মই বহুত বেছি নাম্বার অফ ওয়েজত পাব পাৰো। হৈছে? সো কোনটোৰ probability বেছি হ'ব? 50-50 probability বেছি হ'ব। That means the probability of having 50 molecules here and probability of the molecule 50 molecules in the right side, that probability will be maximum. Okay, now just imagine like this. It is mathematically correct. Just imagine like this. Say I have a gas, all the gas molecules, 100 molecules in this side, and I have partition, and I have removed the partition. If you gas to order di asa, okay, you listen to me and go one by one. Will they go? Eta molecule gol, next he ঘুরি আহিলে, আকৌ next to gol, he ঘুরি আহিলে. Will that happens? No. What will happen? All the molecules will distribute among these. আৰু হেতু যদি ডিস্ট্রিবিউটেড হলে ইপিনে কিমান থাকিব? 50 molecules, ইপিনে কিমান থাকিব? 50 molecules. আৰু হেতুৰ probability কি হৈ আছে? বেছি হয়। That means whenever you remove the partition, all the gas molecules will distribute among the cylinder. That means that is the situation, nothing but 50-50. So 50-50 situation is most probable. আৰু ইপিনে 99টা থাকা আৰু ইপিনে 1টা থাকা, বা all molecules in the left side, all molecules in the right side, হেতুৰ probability কি হ'ব? একদম 0. 0 কেতিয়াও নহয়, probability একদম minimum হয়। Okay, so this state is least occurrence, this state most occurrence. Etu tomar mostly occurred hobo, etu ekdam least occurred. That means all molecules in the left ekdam least, all molecules in the right ekdam least, and 50-50 in the situation ase it will be মানে most highest. Hetu jodi hoy tele entropy to moi calculate korim S1, S2 and S3. S1 is what? L99, or just you can write it L100, R0. This is L0, R100, and this will be L50 R50. কোনটো এন্ট্রপি বেশি হ'ব? whose entropy will be maximum? S2. S1 one of the entropy আছে, it is কি হ'ব? Entropy is minimum. ইয়াৰ entropy টো কি হ'ব? Minimum. and ইয়াৰ entropy টো কি হৈছে? Maximum. হৈছে? এতিয়া তুমি চোৱা, now we see the three situation. এই তিনটা situation তুমি চোৱা। This is my 50-50, but there is no partition here. This is my 50-50. So here for itu is S1, entropy S1, entropy S2, entropy S3. Out of this, S2 has the maximum entropy. তারপর তুমি কি কব পারিবা? What we can say? এই তার ফিজিক্যাল স্টেটের উপর তুমি কি কব পারিবা? What you can say? What physical state? তিনটা physical state to তুমি যদি সোয়া, what difference you are getting? কি difference পাই আছা? এটা তোমার কি হয়েছে? all molecules are situated in the left side. S3 যদি চাও, all molecules are situated on the right side. কিন্তু S2 যদি চাও, moleculeবিলাক কি হয়েছে? distributed among the whole. এতিয়া এই তিনটাৰ পৰা কোনটো বেছি মই orderly থকা বুলি কম? Which states are in most ordered state? S1 and S3 orderly আছে. Why it is orderly? Because they are quietly sitting on one corner. এবাৰ লেফটৰ আছে, নেক্সট আছে ৰাইট. Now you are sitting orderly. So you are orderly. You are ordered state আছে. কিন্তু S2 যদি চাও, there is no restriction. This molecule can go here. This molecule can come here. So there is no restriction. So I can say that this is the least ordered state. Or I can say that most disordered state. Okay, this is the most disordered state or the least ordered state. Paisano buji. So this is একদম disordered হৈ আছে, because কোন কোড আছে কোনো হিসাব নাই। কিন্তু ইয়াত তেনেকুৱা নহয়, ইয়াত কিন্তু একদম পুৰা কি হৈ আছে? ৰাইট সাইডে আছে, ইয়াত কি হৈ আছে? লেফট সাইডে আছে। বাট হিয়াৰ নো ৰেষ্ট্ৰিকশ্যন এট অল, একদম ৰেণ্ডমলি মুভ কৰি আছে, ইয়াৰ পৰা ইয়াৰ, ইয়াৰ পৰা ইয়াৰ, they are distributing. So here it is mostly disordered. So that means randomness কাৰ বেছি হৈ আছে? ইয়াৰ randomness maximum, ইয়াৰ আৰু ইয়াৰ randomness কি আছে? Minimum. আৰু য'ত মোৰ randomness maximum হৈ আছে, তাত মোৰ entropy কি হৈ আছে? Maximum হৈ আছে. So Boltzmann concluded, okay, entropy is nothing but the disordered. It represents the disorderedness of a system. এটা সিস্টেমৰ disorderedness-টো বুজায় entropy. So physically যদি মই বুজিব লগা হয় যে এটা ষ্টেটৰ পৰা আনটো ষ্টেটলৈ গৈছে, তাৰ এন্ট্ৰপিটো বাঢ়ি গৈছে, তাৰ মানে কি হৈছে? ষ্টেটৰ যোনটো সিস্টেম আছিল, সিস্টেমৰ ডিসঅৰ্ডাৰটো কি হৈ আছে? বাঢ়ি গৈ আছে। এতিয়া তোমালোকে ধুনীয়াকৈ বহি আছা, টিচাৰ ওলাই যোৱাৰ পিছত কি হ'ব? ৰেণ্ডমনেছ উইল কাম, নাও ইউৰ এন্ট্ৰপি উইল ইনক্ৰিজ। চ' ইনফেক্ট আমাৰ যোনটো সেকেন্ড ল অফ থাৰ্মোডাইনামিক্স আছে, সেকেন্ড ল অফ থাৰ্মোডাইনামিক্সে কয় যে ইউনিভাৰ্ছৰ এন্ট্ৰপিটো সদায় কি হৈ আছে? বাঢ়ি গৈ আছে। চ' ৰেণ্ডমনেছ ইজ ইনক্ৰিজিং। চ' ৰেণ্ডমনেছটো কি হৈ আছে? বাঢ়ি গৈ আছে। Simply take an example. তুমি you imagine your room, তোমালোকৰ ঘৰৰ ৰুমটো তুমি ইমাজিন কৰা। Suppose Sunday বন্ধ পাইছা, তুমি কি কৰিবা? I assume that তোমালোকে কি কৰিছা? ঘৰ চৰ চব ঠিক ঠাক কৰিছা, টেবুল চেবুল চব ঠিক ঠাক কৰিছা, জাগা জাগা বস্তু লৈছা, জোতা চেণ্ডেল মোজা চব জাগা জাগা আছে আৰু। So all are orderly আছে। So অলপ সময় পিছত তুমি যদি চোৱা, after 1 hour or 2 hour, you will see that কিতাপখনে কিবা বেলেগ হৈ গ'ল, কাপোৰখনে কিবা বেলেগ হৈ গ'ল, জোতা পাতে কি হ'ল, so your orderটো কি হৈ যাব, order will shift towards the disorder. So your disorderness will increase and that will increase spontaneously. And that is why মই আগতে এটা টাৰ্ম তোমালোকক কৈছিলোঁ যে in case of a spontaneous process entropy always increases. That means whenever you take a heat engine হ'লে হিটটো ক'ৰ পৰা যাব, the heat will go from the hotter end to the cooler end, আৰু তাৰ কাৰণে এন্ট্ৰপিটো কি হয়, বাঢ়ি থাকে. Okay, its entropy will increase. So whenever a spontaneous process happens, entropy increases. And spontaneous process happens means your disorderness increases. এতিয়া তুমি যে উল্টাটো কৰিব যোৱা যে you are taking the heat from the cold to the hot, তাৰ কাৰণে তুমি কি কৰিব লাগিব, এক্সট্ৰা এনাৰ্জি দিব লাগিব. তোমাৰ ৰুমটো ডিসঅৰ্ডাৰ হৈ গ'ল, তাৰ আকৌ অৰ্ডাৰ কৰিবৰ কাৰণে তুমি কি কৰিব লাগিব, effort to give an effort, extra effort তুমি দিব লাগিব. Okay, you have to give an extra effort. এতিয়া সেই যিখিনি এক্সট্ৰা এফৰ্ট দিবা তাৰ কাৰণে আকৌ এন্ট্ৰপি চেঞ্জ হ'ব. So ultimately তুমি যদি চোৱা, the entropy of the universe will always become positive. That means disorderness of the universe is increasing day by day by day. Okay, এতিয়া ঘটনাটো হ'ল, to make a thing disordered and to make a thing ordered, which one is easy? Disorder কৰিব কাৰণে easy. You see, that is nature is allowing. নেচাৰটো সেইটো এলাউ কৰি আছে যে তুমি এটা বস্তু ডিসঅৰ্ডাৰ কৰিব কাৰণে তুমি একো কষ্ট কৰিব নালাগে, অটোমেটিক্যালি ইট ইজ ডিসঅৰ্ডাৰ. গ্লাছৰ এটা তুমি পানী এইটো লোৱা, এইটো লৈ পেলাই ইফ ইউ এৰি দিয়া, এৰি দি পেলাই মোজাত পৰিলে কি হ'ব, ভাঙি যাব. নাও ইট ইজ ইন অৰ্ডাৰ ষ্টেট, ভাঙি পেলাই টুকুৰা টুকুৰা হৈ গ'লে কি হ'ব, ডিসঅৰ্ডাৰ. চ' অৰ্ডাৰৰ পৰা ডিসঅৰ্ডাৰ যাবৰ কাৰণে তোমাৰ একোৱে কৰিব নালাগে, জাষ্ট ৰিলিজ কৰি দিলে হ'ল. উল্টাটো কৰাচোন, গোটেই ভাঙি টুকুৰা টুকুৰ হৈ গ'ল, নাও এই গোটেইকেইটা টুকুৰা টুকুৰা আনি পেলাই তুমি জইন কৰি পেলাই আকৌ গিলাচটো আগৰ নিচিনা বনোৱা, হাউ মাছ টাফ ইট উইল বি. চ' টু ডিক্ৰিজ এন্ট্ৰপি ইজ ভেৰি ভেৰি টাফ, বাট টু ইনক্ৰিজ এন্ট্ৰপি ইজ অলৱেজ ভেৰি ভেৰি ইজি. এণ্ড দেট ইজ ৱাই দ্য হোল ইউনিভাৰ্চ ইজ গোয়িং টুৱাৰ্ডছ কেঅছ. ৰেণ্ডমনেছটো বাঢ়ি যাব নেকি, কেঅছটো বাঢ়ি গৈ আছে. So your universe, our universe is going towards a chaos, and in coming days the universe has to be destroyed. Earth will destroy, everything has to destroy, because chaos cannot be indefinite. Chaos to eta homot goi ki hobo, eta equilibrium pabo. দুজন ল'ৰাই কাজিয়া কৰি আছে, প্ৰথমতে মাৰপিট ঠিকে লাগিব, ঘুচা ঘুচি কৰিব, ঘুচা ঘুচি কৰি এটা সময়ত তোমাৰ কি হ'ব, দুইটা আল্টিমেটলি কি হ'ব, এনাৰ্জি লুজ কৰি 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 দুইটা কি হৈ যাব, ফ্লেট হৈ যাব. তাৰপিছত আৰু তেওঁলোকৰ কাজিয়া কৰাৰ কোনো এনাৰ্জি নাথাকিব. চ' ডেট উইল বি কল্ড এজ ইন দ্য এক্সট্ৰিম কেঅছ, এণ্ড ডেট উইল বি কল্ড দ্য ইকুইলিব্ৰিয়াম. তাতকৈ আৰু বেছি কেঅছ হ'ব নোৱাৰে. প্ৰথমতে মুখেদি কাজিয়া লাগিলে, হাতেদি কাজিয়া লাগে, ভৰিদি কাজিয়া লাগি বাঢ়ি 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 এটা সময়ত মাৰপিট কৰি ফ্লেট. চ' মাৰপিট কৰি ফ্লেট হৈ যোৱা মানে দিছ ইজ দ্য মষ্ট এক্সট্ৰিম চিটুৱেশ্যন. তাতকৈ আৰু এক্সট্ৰিম কিবা হ'ব পাৰে নেকি, নাই ন, তাতকৈ এক্সট্ৰিম হ'ব নোৱাৰে. দিছ ইজ দ্য মষ্ট এক্সট্ৰিম. আৰু সেইটো কি হৈ আছে, দিছ ইজ অল আৰ ইন ইকুইলিব্ৰিয়াম, চব শান্ত. তাৰ আগত কি হৈছিলে, যে মাৰপিট হৈ পেলাই কেঅছটো বাঢ়ি 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 বাঢ়ি, the universe also like that. Universe এতিয়া কি হৈ আছে, কেঅছনেছটো কি হৈ আছে, বাঢ়ি বাঢ়ি গৈ আছে. চ' বাঢ়ি 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 এটা সময়ত এনেকুৱা হ'ব যে ইমানখিনি বাঢ়ি গ'লে তাতকৈ আৰু সেই হ'ব নোৱাৰে. চ' ইট উইল কাম টু দ্য হল্ট, গোটেই ধ্বংস হৈ যাব, এভৰিথিং উইল কাম টু দ্য হল্ট, এণ্ড এগেইন ইট উইল ষ্টাৰ্ট, আকৌ নতুনকৈ ষ্টাৰ্ট হ'ব. দেন দিছ ইজ নেচাৰ, এইটোৱে নেচাৰ হয়, ইট ইজ কল্ড এন্ট্ৰপি. So entropy is related to the disorderness, and entropy is maximum at equilibrium. Okay, so this line is important. Entropy is maximum. Entropy is maximum at equilibrium. So whenever you got an equilibrium, your entropy will be maximum. But equilibrium power agolike entropy ki hobo, বাঢ়ি বাঢ়ি গৈ থাকিব ৰেণ্ডমনেছটো বাঢ়ি 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 এটা সময়ত কি হ'ব নো ৰেণ্ডমনেছ অফ এভৰিথিং উইল বি ফ্লেট cool and calm all will be ordered so your entropy will be maximum এটা ulta to question when the entropy will be minimum that means if you want to make the entropy minimum what you have to do you have to come in the opposite direction you have to come in the ordered state এটা ordered to যদি পাব লগা হয় এটা molecule তুমি consider কৰা এটা molecule যদি ordered state পাব লগা হয় কেতিয়া ordered state the most ordered state কেতিয়া থাকিব when a molecule will be at the most ordered state you decrease the temperature decrease kori কিমানলৈকে যাব পাৰিবা 0 Kelvin তলত তো যাব নোৱাৰা so whenever you are reaching 0 Kelvin everything will become stopped all will be ordered and your entropy will be your minimum so entropy is minimum at 0. So these two are very, very important. Entropy is maximum at equilibrium and entropy will be minimum at 0 Kelvin. Okay. So it will, it is definite that universe is going to die. Universe kono eta homayot tomar onko hoboi lagibo because entropy is increasing day by day okay so we now came to know about the physical existence of the entropy to badha mane actually ki hoy ase now we can know যে এটা সিস্টেমৰ কি হৈ আছে randomness to বাঢ়ি বাঢ়ি গৈ আছে আৰু all universe আমাৰ সব সিস্টেম কি হৈ যায় irreversible process হয় আৰু for all irreversible process entropy increases and it is increasing and it is going towards equilibrium and equilibrium to kota ahibo jetia sob onko hoy jabo then will be equilibrium so entropy is going like this so Boltzmann has denoted or described entropy as a disorderness after the explanation of the entropy given by Boltzmann then people try to give another definition like lack of information entropy jodi badhe entropy badha mane tomar ki hoyase information you are lacking why information you are lacking because randomness jimane badhibo himane eta system or tumi information collect kora pariba niki nwariba no jimane stable hoy thakibo himane tarpor basic information lobo pariba jimane unstable hobo himane komke information paba so entropy is also related to the lack of information it is also related to the error of time our earth ba universe kun phale goi ase it is going towards equilibrium so time jin phale goi ase at that time with respect to time your entropy is also what increasing so entropy is also denoted the arrow of time so there are three explanation or interpretation of entropy one is the disorderness one is the lack of information and one is the error of time okay ehini hol tumalokor things related to entropy so we should know about the physical aru etu kotha monot rakhiba je entropy of a universe always better than 0 because all the systems here are irreversible but a system can have eta system of tumi entropy to ki koribo para komabo para ida tumi refrigerator kotha tumi dhora refrigerator tumi bhitoror temperature to ki kora asa komai asa gotike tar thaka molecules bila ki hoyase they are going towards more order কিন্তু হেইটো কৰিব যাওতে তুমি কি কৰি আছা you are giving extra energy and it is giving lots of heat outside গতিকে বাহিৰৰ সাৰাংগৰ entropy কি হৈ আছে সিস্টেমৰ তুমি entropy to কমাব যাওতে you are giving more entropy to the surrounding গতিকে ultimately universal entropy কি হৈ আছে বাঢ়ি গৈ আছে গ্লাস তুমি ভাঙিলা okay very easy ভাঙিলা কিন্তু আকৌ আগৰ জায়গা to আনিব লগা হয় you have to do lots of labor ঘাম চাম ওলাই যাব কিবা হ'ব so you are giving lots of entropy to the surrounding system to আহিব আকৌ আগৰ জায়গাত আহিব you can make it same entropy তুমি কমাই পেলাই জিৰ' কৰিব পাৰিবা কিন্তু ইপিনে তুমি কি কৰি আছা you are giving lots of entropy to the surrounding so as a whole universe তুমি যদি চোৱা universe কিন্তু কেতিয়াও entropy to জিৰ'তকৈ কমিব নোৱাৰে so হেতু আমাৰ এটো বুজাই আছে যে universeৰ randomness or disorderedness to কি হৈ আছে বাঢ়ি গৈ আছে and it will go and it will stop at a time when equilibrium will reach যেটো সময়ত আমাক নোৱাৰ নাওখন লাগা হ'ব যেটো আমাৰ ষ্টৰী আছে না that things will come so there everything will stop and again the life will start from the beginning that will happen আৰু ষ্টিফেন হকিংছৰ মতেটো that day is not far away because এতিয়া যিমান মানুহবিলাকে randomness দি আছে in terms of your infrastructure in terms of factories and all যিমান heat develop হৈ আছে and this AI I don't know how much you like it I think you will like it because কিবা এটা assignment দিলে তোমালোকে you can do it very easily but you know hey AI to run কৰিবৰ কাৰণে how much energy it takes or how much pollution it is giving to the environment it's a huge আর মানুহবিলাকে অকল পইচাৰ কাৰণে only for money they are finding out these apps like ChatGPT and all okay it has now the time has come to stop this AI stop কৰা time আহি গৈছে and it will stop it will not go beyond this এতিয়ালৈকে যিমান আহিলে AI যিমান এডভান্স হৈছে তাতকৈ আৰু বাঢ়িব নোৱাৰে আৰু সেইটো যদি বাঢ়ি যায় then it will be don't test it এইকাৰণে ষ্টিফেন হকিংছে কৈ আছে যে coming 100 years of it is alarming coming 100 years of art will vanish আৰু কোনে কৈ আছে তো ষ্টিফেন হকিংছে কৈ আছে এলাপেচা মানুহে কোৱা নাই who this wheelchair বহি বহিয়ে everything has described সেইজন মানুহে কৈ আছে যে within coming 100 years art খন যাব okay let us stop it here today